Hi, I'm Christopher Schultz. If you were here this morning, you got an entertaining talk, and this afternoon I'll be talking more about security. And the title is Locking Down Apache Tomcat, but we're actually going to talk a little bit more about what Tomcat can do for you and your application. We will cover how to lock down Tomcat a little bit, but for the most part, that's a short conversation. And once again, if you'd like to follow along or grab the slides, QR code will get you there, the link will get you there. And if you forget all about both of those and you go to the Tomcat website, on the presentations page in the next couple of days, I'll be adding this to that page as well. So a lot of application build cycles go, let's build an application and then we're going to deploy it, and then, oh yeah, let's sort of like paint security on top of it. In case anyone hasn't told you, that's a terrible approach. And you have to think about the security of your application and your deployment in your system long before you start trying to take it live. It's not something that you can just add at the end. And I myself have resisted many of these things in my career, like doing risk assessments, because risk assessments is one of the least fun things to do for application developers, and often you leave that to somebody else, right? You hire a CISO, and they have to do the risk assessment. Well, you should sort of be doing a mental risk assessment of everything you're working on, even if you're just programming. So if you have to write a Hello World application or WebSocket endpoint or whatever, you should keep in the back of your mind, this is eventually going to be exposed to the internet, and maybe we shouldn't, I can't come up with a great example off the top of my head in Java, but maybe let's not dereference pointers without checking to see that they're not null or something like that. Pay attention to what you're doing. It's important for you to understand what you are trying to protect and who your adversaries might actually be, because there's always the big bad guys, but then there's always some idiot who's on your local network, and every time you protect your application a little bit better, somebody makes a better idiot. So think about that as well. They don't need to necessarily be a malicious actor. This can just be someone who can take down your site because they're not thinking about something. And please don't forget insider threats. A lot of bad things happen to companies when somebody gets fired but their credentials don't get revoked, and on the way out they do all kinds of damage. So you can't necessarily trust even the people you're supposed to trust. And just because your network doesn't have anyone lurking on it today doesn't mean that tomorrow that's going to still be the case. So I'm going to run through a couple of things quickly here that I'm otherwise not really going to talk about, like physical security. We're basically going to skip all these things and go right down to the server software, but I just want to cover these things so that if you have time some other time, or if you have questions about these things or you've never really thought about them, it sort of seeps into your brain. Do you know where your servers are? Do you know who's managing them? Do you know what the physical layout is of your data center? Do you know who's walking in and out? Who has access to your cages? Who has access to the rooms? Is anybody randomly plugging stuff into your VLAN? You should maybe be concerned about that. How is your network infrastructure built? What is available to the wild internet? What is available to what you consider your local area network or your VLAN? And this type of segmentation is a security precaution you can take. Obviously, public-facing servers need to be looked at with the most scrutiny, but I would argue that your LAN-facing and your VLAN-facing interfaces should also be protected just as well, because as I said before, you never know really who's on your network, whether they're malicious or not. For your operating system and the user running your services, make sure that you keep, I'm going to say this over and over again, keep things up to date. If you have software that's out of date, even if it doesn't have a vulnerability right now, it's eventually going to have one. So get good at staying up to date so that when, not if, a vulnerability is found, you are capable of responding to that. If you are in the habit of deploying a server one time and then just waiting for the hardware to die before you upgrade the operating system on it, you're going to be attacked. And you're going to be successfully attacked. And make your server as dedicated as you possibly can. I'm sure everyone in this room has run a one-box wonder in their life. Database, app server, web server, all kinds of things, web browser, the whole shebang. For real production, don't do any of that stuff. Containers can help a lot with this, because if you start containerizing your services, you have a database, you have an application server, you have a web server, you can still use your one-box wonder locally, but all those services are separate. And then when you want to migrate them to physically different machines or virtualize them, it makes it a lot easier for you to do. For Tomcat specifically, you shouldn't be running as root. I can't think of a very large number of cases where Tomcat was an attack vector. Tomcat itself, it's usually the application. And I don't think that Tomcat is any less secure than, say, Apache Web Server or anything like that. But it's just not a great idea to run the service as root. HTTPD doesn't run as root unless the package manager doesn't know what they're doing. You're usually running as an unprivileged user, and it's just good policy all the time. So please, if you're running Tomcat as root right now, figure out how to not do that anymore. Likewise, don't use a Tomcat user for other things. Lock it down so it's only doing one thing, because that allows you to do some of these other things. For example, if you protect your configuration files, which usually have passwords in them, like, I don't know, a password to your database, or let's say you have a monitoring system which is pinging a service and it has a HTTP basic authentication in there, if only the Tomcat user can read and execute that file, then that means that no other user can do it. And that also means that nobody else is using that user for something else, and then they can subvert it to maybe attack your application. Again, this is sort of for Tomcat, but this can also be applied to your own application as well. Because if your application is running under the Tomcat user, then your configuration files only need to be read by the Tomcat user. Oh, I do want to point something out. Tomcat does need write access to the work directory. So if you decide to lock everything down so that in case there's some type of intrusion and your application or Tomcat itself is compromised, it's a good idea to have nothing writable, but Tomcat actually does need the work directory to be writable, so you can't get away from that. Sorry. All right. Now we're going to talk about real stuff. I've been joking to people about this presentation that, locking down Apache Tomcat just means unzipping it and then you're done. Because out of the box, the configuration is pretty safe. Tomcat does not have any default credentials, so that's not going to bite you. The applications that are privileged, such as the manager and the host manager and things like that, are locked down so that you can only connect to them from the local host. So there's still opportunity for shenanigans there, but if a bad guy is on your host, you probably have bigger problems than whether your Tomcat is perfectly locked down. The applications that it comes with, we consider part of Tomcat. So you can look through the big CVE history of all the Tomcat vulnerabilities from the past, and you'll see a lot of them are silly things like, oh, the examples application has, a cross-site scripting exploit. Okay, like that, we'll give a CVE to that, and we'll fix it. You shouldn't be putting as examples out in the wild, but if you do put it out in the wild, we shouldn't allow you to be exploited for that. So the applications are considered first-class citizens, and we lock those down, or we protect them. The file permissions are a little bit weird. especially if you use a split Tomcat deployment, which I'll talk about a little bit later. But generally speaking, when you untar that package, the config files are only going to be readable by the user that untarred the package. You may need to adjust that, but again, if you can keep those files readable only by that user, that's a win. There's usually only 2 ports that are open. One of them is 8443. One of them is, well, none of these are listed. 8443 and 8080. Sometimes 8009, I can't remember if that's default anymore.
It is.
It is? Okay, so you get, actually the 8443 is not.
Right.
You'll get an HTTP connector on 8080, and you'll get an AJP connector on 8009. You also get a management port on 8005, which is just for shutting down Tomcat. Anyone can connect to that. It's bound to localhost, but if you can get on the box, you can use curl, and you can take down Tomcat. It's fun.
You get on the box.
Sorry?
Shut down. If you get on the box, you can say shut down.
Well,
okay, yeah.
an unprivileged user can make a localhost connection using curl. So one of the best ways to stay secure is to stay current. And I'm probably going to say that 6 more times. So within Tomcat, and these are the things I'm going to cover here, we have some potentially dangerous features. Default applications, the security manager, connectors, which is the communication components, authentication, so that would be authentication for both the built-in applications as well as container managed auth that you can use in your applications. Some of the services that Tomcat can provide through JNDI, and clustering. So let's start with some of the problems that are sort of lurking in Tomcat that you might trip across. And one of them is the APR connector is heavily uses TC native and Apache Portable Runtime, APR. There's nothing inherently dangerous about those components or something that I would say, it's a giant red flag. However, whenever you're running native code and you're jumping back and forth between Java and native, there's an opportunity for, even if it's not a security issue, there's an opportunity for a small problem to turn into a JVM crash. It's pretty rare, but I know for a fact there's a bug somewhere in the byte sender for the APR connector. Occasionally, like once every 2 or 3 months, somebody will report essentially the same issue that we've been hearing for years. There's a null pointer dereference somewhere in there, and I think it might be Windows only or something like that, and we have not been able to track that thing down. The same thing when it happens in the NIO connector, you get an IO exception and everything's fine. That connection dies, gets recycled, and your server keeps running. But when you're running on Windows under the whatever, your JVM is down, like immediately. There's in-flight request, dead. Like your service might be completely down. So I would say that in general, you should try to get away from native components whenever possible. As much as I like the APR connector, given Remy's comments this morning about how it's the highest performing connector that we have, you might say, well, it's worth the risk. Our performance numbers show that you're more likely to fill the network with data before any of Tomcat's connectors become a bottleneck. So the fact that it's the fastest connector, it's like 5% faster.
Yeah.
But you're never going to reach the point where you notice the difference between the two. The manager application, I'm going to talk a little bit later, and I talked earlier today about how much I like the JMX proxy servlet, which is served by the manager. The manager application is, guess what, an administrative tool. Don't expose that to the outside world. If you do, people can undeploy applications. They can deploy new applications. If you've never used Metasploit, look up MS Venom. I'm pretty sure that you can get that wrapped in a war and push that across the network into somebody's manager app, and coupled with a privilege escalation, you can probably get root on something on your network. if you really want to try that out. Server side includes was a feature sort of copied from HTTPD, which has the, I forgot, it's just mod include or something like that. HTTPD guys aren't paying attention right now. Mod include, what's the SSI thing? Server side include for mod include? Yeah, so for some reason we thought it would be a good idea to re-implement that. And it's got a couple of things in it that shouldn't have ever really existed, like exec. And so if this thing is enabled, which is not by default, you're opening yourself up to a couple of potential razors. WebDAV is cool, even though nobody uses it. If you enable read-write, be very careful where you allow it to write, because you can stupidly configure it so that you can write to the config directory, and then you can reconfigure Tomcat out from underneath itself, and bad things can happen. The CGI servlet is basically just a remote execution, remote code execution vulnerability waiting to happen. Please configure that correctly, and in fact, just get rid of your CGIs and implement servlets properly. That would be the best way to do things. JMX is another issue. JMX is a really bad protocol, not for sending data back and forth, but it's very difficult to configure authentication in a sane way. Basically, I don't know if this has changed, but you used to be able to supply exactly one username and one password. You can't really configure it to do anything that's smart. You can do it securely. There is a TLS wrapper for it, but I would always bet on using the JMX proxy servlet, because then you can use all of the wonderful authentication mechanisms that Tomcat can provide. Tomcat has nothing to do with the JMX authentication mechanism. We can't hook into it. We can't replace it. We can't do anything. It's served by the JVM, and it's not great, so you should skip it. You should remove pretty much every application that comes with Tomcat. If you don't need the manager, don't deploy it. Although it is very handy for deployment and monitoring. I run it on all of my application servers, but I lock it down. It's already locked down, and it doesn't have, I mean, if you right now run the server that you just compiled, you will not be able to log into the manager application, even though it's running, because there's no password and no username for it. You'll have to explicitly configure those. But make sure that you don't explicitly deconfigure those just because you were trying to get it working quick and dirty one day, and so you said, I don't need this username and password garbage. I just want to get in. Remember to go back and figure it out. Yeah, it's localhost only by default. And then do you really need the host manager? And I said really here because I've been using Tomcat since 2000. I don't even really know what the host manager does.
Same boat.
Just delete it. Yeah, I don't know. Does anybody know what it does? Great. Just delete it. All right. So I've tried this myself. Tomcat works just fine with a security manager. So if you want to lock down Tomcat, if you run catalina.sh-security, is that it? -security? Yeah. It'll run it with the security manager installed. Everything's fine. Examples work. Whole thing works. Your application probably will not. And that's because in order for your application to do anything useful, it needs to make JDBC connections, and it needs to load jar files, and it needs to make web service calls, and it needs to do all kinds of things that it is not allowed to do because the security manager is not letting it. So you will need to go through a really painstaking process of launching your app, watching all the errors that occur, and then writing a policy file that will allow all of those things to happen. Most application developers, myself included, have decided that this is not an exercise worth going through. If anyone has the opposite experience and has done it and likes the results, I'd love to hear from you in the hallway outside. because this is actually something that I would like to do personally. It just seems like such a pain in the neck. Take a look at the connectors that you get by default. I mentioned that you'll get an AJP connector on port 8009, and you'll get an HTTP connector on port 8080. If you don't use AJP, kill it. There's no reason to have anybody pinging that port if you're not expecting to get requests on it. Consider IP filtering. You may not even need localhost access. If you're expecting a reverse proxy to be communicating with your Tomcat, you don't need loopback access. So feel free to lock down your server so that it'll only respond when you get requests coming through the reverse proxy. You can lock down the whole server, or you can lock it down on a per application basis. And that can be done using filters or valves, which can be configured at any of those levels. So you can do it in server.xml up here, or you can do it right in your own application in context.xml. It doesn't go in web.xml unless you use the filter, which is weird. You may as well use a valve and get it killed at the earliest possible point. Some considerations for reverse proxying is I would recommend that between your proxy and your Tomcat server, you set up encryption. On one of my earlier slides, I suggested that maybe your network isn't as secure as you think it is. I had somebody at our data center accidentally plug something into the wrong port, and we had an additional host on the network that we should not have had. But we've always encrypted everything, even on our own VLAN, which is supposed to be secure. And when we noticed this host on the network, I called up and said, "What is this?" And they said, "Oops." Well, that oops could have been listening to all the network traffic. So if that oops happens in your environment and you're not encrypted, they've just captured, or could have captured, whatever was floating across your network. So please secure everything. And I would like to point out again that AJP does not provide encryption. We talked about this in various forms this morning. There are ways to get it done, and I'll hit that in a second. So I talked about Let's Encrypt earlier, and there are a bunch of TLS presentations on the Apache Tomcat website. If you are not comfortable with TLS, configuring it, generating a certificate, that kind of thing, get comfortable with it. It's pretty much par for the course these days. Here are some ways that you can protect Tomcat connectors. You can protect the shutdown port with a password. It's pretty easy to configure. You just throw another attribute in your configuration file. It's not super secure. Anyone can connect to your socket and send a shutdown string to you. And we will only ever bind to localhost, so you can't filter out localhost. The best thing that you can do is to disable the shutdown port if you don't want anybody doing that. And remember, this is across a socket, so you need no administrative privileges at all. Any user who's on that box can use curl to, or not curl, can actually use NC, netcat, yeah. Yeah.
Why don't we just disable it by default?
Because if you don't allow that to happen, you basically need to kill the process a little bit less cleanly.
Instead of a graceful shutdown.
Well, it still does a graceful shutdown, but it's a little nasty. Was there another question over here?
Yeah, well, it's kind of the same line. If I disable the port and then I need to do some maintenance, I'm thinking that it's going to be restarted if I have some process that is just looking at the service and trying to make it alive again, right?
Yep. So if you use the Tomcat scripts to start and stop, or if you use a Windows service, if you disable this port, it will still work. It just uses a different technique to start it up. Excuse me, to shut it down. It sends signals essentially to stop the service. So it will work. It's just a little bit. it's a little bit less clean. Yeah.
So on Windows, because there's no signals, if you don't have a shutdown port, what does it do? Do you know?
No. I do not know the answer to that. So if you guys didn't hear that, he said on Windows, since it doesn't use signals, does it still work?
Yeah, it did.
So if you're using the Windows service,
Yeah, you don't
it
need
does
it.
work because
Yeah.
we're using the service wrapper.
Right, yeah,
And the
you just
service
run
wrapper does a clean shutdown. Yeah. You can protect the AJP port with a password. You just put this thing called required secret in here, and then on your HTTPD side or Nginx or whatever, you have to put the same secret in there. It's a pre-shared key. This offers virtually no security. Secret is exactly as secure as HTTP basic authentication, which is to say, not. However, S-Tunnel works very well, and that's what I've been using in production for years. SSH tunneling can do it as well, but for anyone who's ever had to try to maintain a persistent SSH tunnel using like SSH, you know that it's kind of a pain in the neck. And if that's what you want to do, S-Tunnel was built for that exact thing. So please just use S-Tunnel. And as we were discussing a little bit earlier, maybe it's just time to let AJP go and switch to HTTP.
I don't think you can do even on Nginx with the AJP. I run Nginx with Tomcat, I always use the HTTP.
I think it's there. It might be being phased out, or it might be gone already. I'm not sure. I know that HTTPD is not the only server in the world that does it.
IIS does it.
Well, because we do it. Because we supply ModJK. So, really quickly, since I mentioned S-Tunnel, and I think I'm totally fine on time. I started at like the hour, right?
You satisfied?
Yeah.
Cool. All right. So S-Tunnel can wrap any connection, any socket connection in TLS. It adds encryption, authentication, and mutual authentication. So if you want to connect securely from, let's say, your web server to your application server, or vice versa, because it doesn't really matter which direction the tunnel is set up, it's bidirectional. You want to make sure that, let's say that your application server is hosting the service that's being connected to from S-Tunnel. Your application server wants to make sure that you don't just have randos on the internet connecting to your service over S-Tunnel, so you put a client certificate on the web server so that it authenticates the client, and then the client authenticates you, and you have a nice secure tunnel between the two. So I would highly recommend that if you're going to use S-Tunnel, you use client certificates. And that's how you do it. If you've never seen an S-Tunnel configuration file, this is missing a lot of things, but that sets up client certificate, a client certificate trust store, essentially. Verify says, yes, please actually verify these things. And then you would say, except on localhost 8008, I just made up a port number. That's the TLS port that you'll be listening to. And then S-Tunnel will basically, it terminates TLS here and then puts the unencrypted connection connected to whatever is down here. So you're saying, take this incoming connection from my web server, it's connected via TLS, and embedded inside of it is an AJP connection, and then raw AJP comes out the other end to 8009, just like you didn't care about security and you had your unencrypted connection directly to it. And just in case you didn't know what goes into this file, the Trusted Client Certificates file, if you would look at that, it has all the begin and end certificates. You just concatenate them all together.
Does it matter?
Nope. Would it? No, the order doesn't matter.
Does the documentation have something related to S-Tunnel?
Nothing whatsoever. So there it is.
Okay.
Tomcat can manage your authentication, and I feel like I might be the only one in the world who's interested in getting this working, because everybody 10 or 15 years ago moved on. They all use Spring Security or some hand-rolled thing or some third-party library. And container managed authentication is something which is mandated by the server spec, by the servlet spec. And Tomcats didn't really change since 2003 or so, until a few years ago when we gave it a serious upgrade. It is currently used to protect Tomcat's bundled applications, so the manager and the host manager, whatever that is, and the examples application. But it can protect your application as well. And I would submit to you that you don't need to add a third-party security library to do authentication for you, because Tomcat's authentication is quite rich. I will add a caveat to that, which is that I am not currently using it. It's missing one feature, which I am working hard to get in there so that I can switch to it. So Tomcat's authentication supports a number of different backends. You can use a relational database. You can use a flat file. There is one that's been used as an example for a really long time. It's the Tomcat users XML file here, which I only found out this morning will auto-reload now.
Yeah,
that's cool.
yeah.
You can use LDAP, so if you have Active Directory managing your network, or OpenLDAP or something like that, you can use that for authentication. And then you can use this thing called JASPIC. I don't remember what that stands for, but it's essentially like when a whole bunch of people got together who just love to geek out about authentication and said, let's build one API to rule them all. That's it. And it's implemented in Tomcat, and my guess is that any new features that get added to authentication mechanisms are very likely to get sort of put into here as time goes on. So I need to make it a point to learn how to do that, because I have no idea. Credential protection, that is maintaining credentials for users in a non-plaintext form, is something that Tomcat has always done, but this is one of the significant upgrades we gave to it recently. It used to be that you could get a single round of anything that Java's message digest class would do for you. So you could get MD5 or SHA-1 exactly one time. No salting, no iterating, no stretching, no nothing. And we fixed all that. And you can now use either hashing or KDF, something like PBKDF2, which is somewhat of an industry standard. I have a presentation, on seamless upgrades for credential security, taking you from MD5 or whatever you had before to something which is much better. In it, I talk about how you can not only change your authentication, your credential storage in your backend, so you can basically take users who already exist and have credentials stored in an old format and essentially auto-upgrade them to a newer, better format. I have examples for how to use bcrypt as your hashing, it's not really hashing, but your key derivation, and how to do time-based one-time passwords, so Google Authenticator on your phone. And the next time I can deliver that presentation, which will probably be next year, I'll also add how to do Argon. Examples with full source code and everything like that. It's actually quite simple to do out of the box. And, because I like talking about this, your application can use it not just to perform the authentication, but when you want to have users, go in and click on my profile and change my password for a new thing, you can grab a component out of the application scope and interrogate it, or you can use it to perform that password mangling. So you can say, here is the user's new password, tell me what I need to store in my database, and it will hand you the thing back. You don't have to know exactly how it's configured. Tomcat clustering is, I think this is the last thing I was going to talk about, the sharp edges. Membership can be done with static membership, which I was very happy to see is easier to do now. Or you can do multicast, where it's essentially polling the local network to find out who wants to be a part of the cluster. And it might not be a bad idea to only use static membership if you don't trust everything on your network. Because if something can just raise its hand and say, yep, I'm in the cluster, do you trust it? I don't know. Using the, it's not exactly, it's still dynamic membership, but it's not multicast. The Kubernetes stuff, that's
but it's
managed
secure.
Dynamic.
It's secure because you have your pods, you know them, so.
Right.
It's just that you don't know the IP of the pods. That's the problem.
Right.
So you have to use the QB REST API to pull that.
Yeah. And instead of using multicast, it's using, well, even if it is using multicast, which it's not, it's communicating over HTTPS, right?
Yeah, oh yeah, it's totally super secure.
Okay. Tomcat's cluster component uses Java serialization to send its data back and forth. And a couple of years ago, some of you may have heard about this Commons Collections attack, where you could inject data into a component that was expecting to deserialize a Java object. And you could poison that to basically do arbitrary remote code execution. And because the clustering wasn't being authenticated, you never really knew where the data was coming from or why. And that type of thing could happen again. So one way to fix that is to enable encryption on your cluster. I get more credit than I deserve for doing this. I screwed it up really badly, actually, the first time I did it. But essentially, you have a pre-shared key, and you just tell all of your nodes, here's your magic key, and that's it. There's really nothing else to do. You have to be a little bit careful about where you put your interceptor, and I specifically put this TCP failure detector down here because the order of these interceptors is important, and this one needs to be further down in the list. There's actually a check when this thing starts up. It examines its siblings and makes sure that you don't have it out of order. And it will just give you an error message that says, like, you need to move me, and it won't start. Okay, so protecting your application. You should try to make some good decisions here. Tomcat can provide some protections, and it only makes sense to use the ones that you understand and that make sense in your environment. So I'd love, as I said before, for you to use Tomcat's authentication. Do not roll your own. You should not be hashing your own passwords in your own application, even if you give it out to some third-party library or something. Let somebody else do that for you, and Tomcat can. Configure access control for incoming connections using, for example, the remote IP valve or the remote IP filter. That's where you can lock down and say, I'm not willing to accept connections from everywhere. Please only allow me to accept connections from my load balancer or my Verse proxy or whatever. You can cobble together some DOS protection using there's a semaphore valve, which doesn't actually do anything. I've seen questions, how do I use the semaphore valve? And the answer is you have to extend it and do something useful with it. But the semaphore valve can be used as a base to create basic DOS detection where, or not DOS detection, but at least DOS prevention, where you can say things like, I'm going to track the number of times a particular IP makes a request in a certain period of time. And if it's going too quickly, I'm just going to start throwing its requests away. But that's something that you have to build yourself. Might be kind of a fun presentation in the future TomCat Con if someone wants to build that and then present it.
Actually, I'd be happy to talk to you about it.
Oh, I'm trying to encourage the community.
Oh, I'm sorry. I will not talk to you ever about it.
Tomcat has some additional protections like cross-site request forgery using the CSRF prevention filter or the REST CSRF prevention filter. Cross-origin request sharing using the CORS filter here. And any HTTP request header or response header that you want to use using this HTTP header security filter, which has sort of become a dumping ground for all these new HTTP response headers. They're all hints that you can give to the browser about how it should behave, involving requests across domains and things like that. I'm not going to go into super fine detail in all of these things, but I will talk about some of them in just a second. These Tomcat protections require that you really understand what's going on. It's not just, oh, if you want to be secure, enable this thing. because a lot of these things, if you just turn them on, your application will stop working. So you have to make sure that your application works correctly with these things, and the only way to do that is to really understand what they're doing. If you don't understand in detail what cross-origin request sharing or cross-site request forgery is and how to mitigate it, don't enable those protections without understanding it and then testing with your application, because there are some sharp edges there as well. Here's a good example, CSRF. So the attack vector is actually you, and what the attacker generally does is they will find a website which is not under your control, and they will find like an XSS, cross-site scripting vulnerability. They trick you into going to that site and poison the page you're looking at over there with a URL that will be automatically loaded on your site to do some administrative action, because you're probably logged in as admin, right? So why not execute like /myapp/delete/user1? Because that would be funny, right? That's exactly what this is, okay? They're betting that you're logged into a site that they have a URL that knows that it does something and that you have administrative privileges, and that when they execute that thing, it's going to do it. And guess what? You get logged as the one who performed that delete, right? So the mitigation is to sign all of the URLs that are generated by your application on your pages, and then those nonces are checked on the request side when you make that follow-up request. So you're looking at a page, 1 second, Daniel. You're looking at a page and it has like, click here to delete this user or whatever. And when you click on that, the URL that goes to your application says not only delete the user, but my CSRF token is fill in the blank. And then the CSRF prevention filter looks at all the incoming URLs and says, is this a currently valid token? And if it's not, it throws the request out. If it is valid, it allows it to continue. And then when you generate your next page, a new token is generated. So basically, every URL that's generated by your application is now unique. It's just like if you put like the JSession ID token in your URLs, you no longer need cookies in order to maintain state across requests. It's literally the exact same thing, because if the JSession ID thing works across your whole application, then the CSRF filter will work as well, because Tomcat uses that same mechanism to hook in and add that token to the end of your URL. Daniel, did I already answer your question?
Tomcat will generate those tokens.
Correct. And then you have to do some things like, there's obviously, your login page. You probably don't want your login page to require the token to get in, because you won't get it. You won't be able to make the initial request to the login page. That's why I said you need to understand the implications of turning these things on, because they might make your application stop working. There's also, let me go back here. There's the REST CSRF prevention filter. Works a little bit differently, because REST very often does not generate web pages. So you need to figure out how to get a token for a REST request so that you can then make a legitimate REST request. All right. X whatever. There's a whole bunch of them. I mentioned this before. It gives hints to your clients to the web browser. When I say client, I mean web browser here. You need to understand these things. If you don't set up HSTS correctly, you can basically knock your site off the internet. So don't do that. Make sure that you test it and understand what you're doing, because if you tell the world that you want HSTS and you configure it incorrectly, all the browsers are going to say, "Whoa, something's funny with this site," and you'll basically ban all of your users from getting to your site for a really long time. So make sure you do that correctly.
That's the one that forces the browser to go to HTTPS.
Correct. But you can make mistakes like, for example, I think you can require that the certificate is signed by a specific CA, and if you get that wrong, it won't match, and you're done. And when I say you're done for like whatever the expiration date is for your HST, etc. And they all tell you to do 18 months. So don't do it wrong. All right, so here's some specific recommendations. Always run the latest release of Tomcat. I cannot stress this enough, even though, as Igal pointed out to me last night, I don't do that. I run almost the latest release. This means that you have to have administrative competence, okay? Become an expert at deployments. I have met people at Tomcat cons and Apache cons who have said to me, it's such a pain to upgrade Tomcat, that's why I never do it. And I say, whoa, whoa, whoa. You're doing it wrong if it's a pain. I highly recommend, and I have to figure out a way to get this to happen, split Catalina Home and Catalina Base. That should be like the default for everyone ever. Because, briefly, you untar Tomcat over here, and then you never touch it. And you build a directory structure over here where all your applications go, and to upgrade, you don't replace anything over here. You untar or unzip another version of Tomcat right next to it, you change an environment variable, and you restart your application. That's it. That should be the upgrade process. And if it doesn't work, to downgrade, you just move the environment variable back to the old one and start up again. And then you figure out what went wrong and you try it again. It should be that simple for everybody. If it's not, you're doing something wrong, or your application is overly complicated to configure. Apply encryption everywhere, even on your local network. Use STunnel for AJP. All three of these protocols can be configured to use encryption. I haven't seen a JDBC driver that doesn't allow TLS connections. It's usually some magic soup that you put into the connection string. LDAP does it right out of the box. SMTP can be done. You need an SMTP.properties, or no, it's mail.properties, and it's very verbose, but it can definitely be done. If you're interested in doing this and you can't figure out how to do it, post something to Tomcat mailing list, I'll help you do it. This goes back to my thing about what I don't like doing. Write an auditing plan, and then actually codify it in software so that you can have monitoring tools automatically validate that what you expect to be in place is actually in place. Do periodic auditing scans, and I'll give you a whole list of tools in a minute to do that. And then actually execute your auditing plan. Don't just write it down and say, look at this beautiful auditing plan, I'm gonna stick it in my file drawer, and we won't look at it until the feds start knocking on our door to figure out why we got compromised. Like, actually execute your plan and automate whatever you can. There are a lot of great tools out there, completely free, open source, etc. If you haven't heard of SSL Labs before, or Qualys, familiarize yourself with them. These are open source monitoring tools. If your organization is not using real-time monitoring, Google these things and figure out how to use something like it. Nmap, Nikto, OpenVAS, a bunch of things. You can find all references to all of these just in Wikipedia, in OWASP, just by Googling for them. They are usually pretty light website scanning types of things. You can just point these things at your site and say, is there anything really obviously wrong with my configuration? They're not super great. I would say that they're the lowest bar that you should be able to cross in order to be competently running a site, but it catches stupid things that are easy to take care of. So run these tools, see what happens. Even using a bad tool is better than using no tool. OSSec, Tripwire, there's all kinds of things you can use to lock down or at least observe your operating system. And those things can be used not necessarily to keep bad things out, but if something bad gets in, you can at least find out that it's there. Oh, sorry. And then there are tools like Bro, Snort, Security Onion. These are things that are real-time monitoring that can watch things as they happen. And actually, some of them, Bro, for example, is actually retrospective, but you can run it sort of real-time by running it a lot by running very high frequency. And then I have not looked into this myself too much, but I would really like to become competent in mod security with Apache HTTPD because a web application firewall sounds like a good idea to me. So I'd love to. Anybody use mod security? 2? Yeah? Okay. You fixed it. Okay. So here's some resources for your security needs. There's the security how-to for Tomcat. Everything that I talked about today is in that document. I went in a lot more detail about how Tomcat can help your application, but in terms of locking things down, you know, disabling the connectors and deleting the applications and all that stuff, that's all in the security how-to. If it's not written well, or you can't understand it, or you can't do it, let us know, we'll fix it. All the presentations today and tomorrow will be on this presentations page. There's also a wealth of previous security and non-security related presentations that are up on the Tomcat website. Join the mailing list, the users mailing list. We'd love to hear from you. We are a community which exists to serve the community. So whatever your needs are, let us know. OWASP is a great group of people that also happen to have a website which publishes a lot of their stuff. There are a lot of security guides out there on the internet, and a lot of them are out of date. So if you Google right now for like Tomcat secure production deployment or something, you can get a lot of Tomcat 6 material for some reason. I don't know why. Apparently 1 year everybody got together and said Tomcat 6 needs to get locked down, and then they never wrote anything after that. Just be aware that the version of Tomcat that's being covered by the guide might not be the one that you're still running. So I would point you to here and not really to any of the other things that are on the internet.
Very quickly.
All right. Yeah. I think we have 5 minutes before the next person has to start talking.
So I know nothing of this myself, but a product manager asked me about it last week. Do you know anything about FIPS compliance with Tomcat?
I do. Somebody correct me if I'm wrong, but I believe that if you use the JSSE crypto, so Java-based crypto, that module is FIPS compliant. I don't think you need to do anything. However, there are a certain number of, specifically for TLS, I'm assuming you're talking about here, there are cipher suites that Java provides which are not allowed under FIPS. Now, I think their list of cipher suites is stupid because they never remove anything. So things that are known to be not a good idea are still like required by FIPS. So I would say that you should read up on the JSSE FIPS compliance and then also still make good decisions. If you want to use the OpenSSL connector, I'm sorry, the AJP, let me try again. The APR connector. Now, I don't want to say TC native because TC native is required for the NIO connector to use OpenSSL. So I'm specifically talking about the APR connector. The APR lifecycle listener has a FIPS switch that you can flip on there. And there are like 3 modes, which is you must enter FIPS mode, or you must already be in FIPS mode, or something else. I've forgotten. If you configure it properly and Tomcat starts up, you're good. I don't believe, and maybe you can tell me if it's, because it's on the APR lifecycle listener,
Yeah.
I don't think it will configure the NIO connector running OpenSSL. I will have to look into that.
Yeah, I don't know.
Okay.
I
And of
didn't
course-
do it, so.
And of course, you need a FIPS compliant OpenSSL
Yeah,
binary,
that's the biggest point.
which
yeah.
is a big pain in the ass to build. All right, anybody else? I'm here all of the week. Thanks.